Here's an overview of the comprehensive production process of clock manufacturing in a factory setting. 1. Design and planning. Concept development. Engineers and designers create sketches and digital models of the clock, considering aesthetics, functionality, and materials. Technical specifications, dimensions, materials, movement type quartz, mechanical, atomic, power source, and additional features, alarms, chimes, smart functions, are defined. Prototype creation. A working prototype is built to test design feasibility and performance. 2. Material selection and procurement. Metal components, brass, steel, or aluminum for gears, hands and casing. Plastic components, injection molded plastic for housing and dials in budget models. Glass or acrylic, used for clock faces and protective covers. Electronic parts, quartz crystals, circuits, batteries, and LED LCD displays for digital clocks, wood used in premium wall and grandfather clocks. 3. Movement production quartz or mechanical. Quartz movement. Circuit board assembly. Microprocessors and electronic components are soldered onto the circuit board. Quartz crystal installation. Generates vibrations that regulate timekeeping. Battery connection. Provides power to the movement. Motor and gear train. Converts electronic pulses into mechanical movement of the hands. Mechanical movement. Gear cutting. Precision cut gears and wheels are created from brass or steel. Spring and escapement assembly. The mainspring stores energy and releases it through the escapement for accurate timekeeping. Balance wheel and regulator. Regulates the clock's ticking rate. Manual testing. Movement accuracy is checked and adjusted. For dial and hands manufacturing. Dial printing. Numbers, markers and decorations are printed or embossed. Hand fabrication, metal stamping or plastic molding is used to shape the hour, minute, and second hands. Painting and coating. Protective finishes ensure durability and visibility. 5. Case and housing production. Injection molding plastic cases. Heated plastic is shaped into clock casings. Metal fabrication, steel, aluminum cases, metal sheets are stamped, cut, and polished. Woodworking, traditional clocks. Wood is cut, carved, and varnished. 6. Assembly process. Movement installation. The mechanical or quartz movement is placed inside the casing. Dial and hands attachment. The dial is secured, and hands are mounted precisely. Glass or acrylic covering. Protective covering is attached using adhesive or clips. Back cover and battery installation. Secured with screws or snap-on mechanisms. 7. Quality control and testing. Time accuracy testing. Clocks are monitored for precision over 24 to 48 hours. Durability testing. Stress tests simulate long-term use. Environmental resistance. Some clocks undergo temperature and humidity testing. Auditory testing. For mechanical clocks with chimes or alarms. 8. Packaging and distribution. Final cleaning and inspection. Polishing and removing any defects. Distribution. Sent to retailers, wholesalers, or directly to customers. Let's break down the comprehensive clock manufacturing process in even greater detail, covering each stage with advanced insights. 1. Design and development. The first step in clock manufacturing involves extensive research and development R&D to ensure efficiency, aesthetics, and functionality. Concept and blueprint creation. Designers use CAD, computer-aided design software to develop 2D and 3D models of the clock. Factors considered: size, materials, movement type, power source, and additional features. Smart connectivity, alarms, chimes. For luxury clocks, aesthetic elements such as engravings, gold plating, or wooden craftsmanship are included. Prototype development. 3D printing or hand-built prototypes help manufacturers test the physical and functional aspects before mass production. Functional testing. The prototype is tested for mechanical movement accuracy, electronic performance, and durability. 2. Material selection and procurement. Different materials are chosen based on the type and style of the clock being manufactured. Mechanical parts. Brass and steel, used for gears, springs, and balance wheels in mechanical movements. Synthetic jewels, sapphire, ruby, act as low-friction bearings to reduce wear in high-end mechanical clocks. Clock housing. Wood, mahogany, oak, walnut, used in high-end grandfather clocks and wall clocks. Plastic ABS polycarbonate, used for modern and budget-friendly clocks. Metal, aluminum, stainless steel, brass, used in premium table and wall clocks. Glass or acrylic, protects the dial and can be anti-reflective or electronic components for quartz and digital clocks. Quartz crystals, used in quartz clocks to regulate time. Microprocessors and circuit boards, found in digital clocks. LED LCD screens, used for smart digital clocks. 3. Clock movement manufacturing. The movement is the heart of a clock. It determines accuracy, durability, and power consumption. A quartz movement production. Quartz clocks are low maintenance and highly accurate. 1. Circuit board assembly. Microprocessor soldering. A tiny electronic chip controls the timekeeping. Quartz crystal attachment. The crystal vibrates at 32,768 Hz, sending pulses to the processor. Stepping motor integration. Converts electrical pulses into mechanical motion to drive the hands. 2. Quality testing. Oscillation frequency test. Ensures the quartz crystal is vibrating correctly. Power consumption test. Determines battery efficiency. B. Mechanical movement production. Mechanical movements require hundreds of precision parts, assembled manually or by automation. 1. Gear cutting and milling. CNC computer numerical control machines carve metal gears with microscopic accuracy. Gears are heat-treated for durability. 2. Spring and escapement assembly. The mainspring stores energy. The escapement wheel controls time release, regulating the second-hand motion. 3. Balance wheel and regulator installation. The balance wheel oscillates back and forth to regulate time. The regulator adjusts the movement speed. For lubrication and assembly. Synthetic lubricants are applied to reduce friction. Skilled technicians assemble the movement using microscopes for precision. 4. Dial hands and face manufacturing. The dial, or clock face, displays time and must be visually clear and durable. A dial printing and etching. Silk screen printing, used for mass production of numbers and markers. Laser engraving, used for luxury clocks to create detailed numerals and patterns. Hand painting, applied in artisan-made clocks. B. Clock hands manufacturing. Stamping process. Metal hands are cut using high-precision stamping machines. Balancing process. Ensures the hands do not wobble during movement. Coating and painting. Anti-corrosion coatings are applied. C. Protective cover production. Glass tempered or mineral crystal, scratch-resistant, and durable. Acrylic or plastic covers. Used in cost-effective models. 5. Clock case and frame production. The case protects the internal components and contributes to the clock's aesthetics. A. Plastic cases for budget models. Injection molding. Molten plastic is injected into molds. Cooling and finishing. The case is cooled, cleaned, and polished. B. Metal cases for luxury or industrial clocks. Die casting used for steel or aluminum cases. Machining and polishing. Cases are polished for a premium finish. C. Wooden cases for classic wall and grandfather clocks. CNC carving or handcrafting used to shape ornate wooden frames. Staining and varnishing. Protects against moisture and aging. 6. Final assembly process. Now all components come together. A. Movement installation. Quartz or mechanical movements are securely mounted inside the case. Screws or clips hold the movement in place. B. Dial and hands assembly. The dial is attached using glue or screws. Hands are press-fitted onto the movement spindle. C. Glass or acrylic covering. The front protective cover is installed using adhesives or locking mechanisms. DI back cover and battery installation. Quartz clocks have battery compartments sealed with screws or clips. Mechanical clocks receive winding mechanisms. 7. Quality control and testing. Before shipment, clocks undergo extensive testing. A. Accuracy testing. Quartz clocks are tested with electronic timekeeping systems. Mechanical clocks are tested in 6 different positions for precision. B. Durability and environmental testing. Clocks are exposed to temperature and humidity chambers. Drop tests are performed to check impact resistance. C. Sound and noise testing. Chiming clocks are tested for tuning and volume consistency. Tick sounds are checked for consistency and acceptable noise levels. 8. Packaging and distribution. A. Packaging process. Bubble wrap, foam or custom molded inserts protect clocks during shipping. User manuals and warranty information are included. B. Warehousing and distribution. Products are stored in climate-controlled warehouses. Distribution is managed through retailers, e-commerce, or direct-to-customer shipping. Final thoughts. The manufacturing of clocks is a blend of art, precision engineering, and modern technology, whether it's a simple quartz wall clock or an intricate handcrafted mechanical masterpiece. Every clock goes through a complex journey from raw materials to a finished timekeeping instrument. Since you want an even deeper exploration of clock manufacturing, let's go into the technical precision, automation, and craftsmanship involved at every stage of production. Comprehensive clock manufacturing process. 1. Research and development (R&D). Before production begins, extensive technical research, prototyping, and market analysis occur. A. Market research and innovation. Consumer preferences, trends, and competitive models are analyzed. Smart features, Wi-Fi, Bluetooth, voice assistants, and modern aesthetics are studied. B. Engineering and CAD design. CAD computer-aided design software. AutoCAD SolidWorks creates 3D prototypes. High-precision simulations check for gear efficiency, wear resistance, and power consumption. C. Functional prototyping. 3D printed prototypes test component integration. Mechanical movements are hand-assembled to verify escapement accuracy. 2. Material selection and procurement. The raw materials must meet precision, durability, and aesthetic requirements. A. Metals, mechanical components and frames. Brass and stainless steel, used for gears and cases due to corrosion resistance. Titanium and aluminum, found in high-end clocks for lightweight strength. Gold plating, luxury models, used for decorative accents and anti-tarnish properties. B. Plastics, casings and digital components. ABS and polycarbonate, injection molded for lightweight and shock resistance. Recycled materials, used in eco-friendly production. C. Synthetic and natural materials. Wood, mahogany, walnut, oak, handcrafted into grandfather clocks and premium wall clocks. Synthetic jewels, sapphire, ruby, act as low-friction bearings in mechanical movements. D. Glass and acrylic, sapphire, crystal, scratch-resistant covers for premium clocks. Anti-glare glass, used in high-precision wall and digital clocks. 3. Precision movement manufacturing. The movement is the engine of a clock, requiring micron-level precision. A quartz movement fabrication. Circuit board assembly. SMT surface mount technology places microprocessors. Quartz crystal integration. Vibrates at 32,768 Hz for accurate timekeeping. Microstepper motor installation. Converts electronic pulses into precise hand movements. B. Mechanical movement crafting. Mechanical movements require hundreds of components, often handy. 1. Gear and wheel fabrication. CNC milling plus or minus 0.001 mm precision. Cuts brass and steel gears. Gears are hardened using heat treatment for wear resistance. R. 2. Escapement and balance wheel production. The escapement regulates time release. The balance wheel oscillates at a precise frequency, controlling movement speed. 3. Spring winding and barrel crafting. Mainspring tension calibration ensures consistent power delivery. Manual lubrication with synthetic oils reduces friction. 4. Hand assembly and regulation. Technicians hand assemble gears, escapements, and regulators. Regulation tests ensure plus or minus 2 to 5 second day accuracy. For case and housing production. The casing determines durability and aesthetics. A. Injection molding plastic casings. Molten plastic is injected into multi-cavity molds. Cooling and trimming remove defects. B. Metal fabrication premium cases. Die casting and CNC machining create durable cases. Polishing and electroplating add protective finishes. C. Handcrafted wooden cases. CNC carving or hand carving creates detailed traditional clock frames. Varnishing and staining ensure moisture protection. 5. Dial hands and numbering. The clock face must be highly visible and durable. A. Dial manufacturing, screen printing or pad printing, applies numerals. Laser etching creates detailed B. Hands crafting. Stamped from aluminum or brass for lightweight precision. Coated with anti-corrosion material for durability. C. Numeral application. Printed, embossed, or hand-painted numbers are applied. 6. Assembly process. After manufacturing individual parts, assembly takes place. A movement installation. Quartz or mechanical movement is secured inside the housing. Shock-absorbing mounts are added to high-end models. B. Hands and dial installation. Precision press fitting ensures hands move without obstruction. Microscopic adjustments align hands with second markers. C. Protective covering attachment. Glass or acrylic face is sealed using adhesives or mechanical locking. 7. Rigorous quality control and testing. Each clock undergoes several precision tests before shipment. A timekeeping accuracy tests. Quartz clocks, verified against atomic time standards. Mechanical clocks, monitored for 6 positional accuracy variations. B. Durability and stress tests. Drop and impact testing simulates real-world conditions. Temperature and humidity chambers, check for environmental resistance. C. Sound and chime testing. Grandfather clock's chimes are tuned manually. Ticking noise is measured to meet sound level specifications. 8. Packaging and distribution. Final packaging ensures protection during transport. A protective packaging. Shock-absorbing foam inserts prevent breakage. Anti-static wrapping protects electronic components. B. Labeling and serialization. Each clock receives a unique serial number for tracking. Luxury clocks come with authentication certificates. C. Global distribution. Clocks are shipped to retailers, distributors, or direct customers. Advanced and future clock technologies. Clock manufacturing continues to evolve with automation, AI, and smart integration. 1. Smart clock technology. AI and IoT integration. Clocks sync with smart home systems. Self-calibrating movements. Adjust based on atomic clock signals. 2. Advanced automation in production. Fully robotic assembly lines. Reduce human error. AI-based quality control. Detects micro defects. 3. Sustainable manufacturing. Recycled materials reduce environmental impact. Solar-powered and kinetic clocks minimize battery use. Let's go even deeper into the most advanced aspects of clock and watchmaking. Focusing on mechanical craftsmanship, high-tech automation, and luxury production techniques. 1. Mastering mechanical clock craftsmanship. Mechanical clocks are engineering masterpieces, relying on complex gears, springs, and escapements to maintain precision. A components of a mechanical clock. 1. The mainspring power source, a coiled strip of metal that stores energy when wound. Crafted from high-carbon steel or modern alloys, like Niva Flex for long-lasting tension. 2. Gear train, energy transmission. Converts stored energy into regulated motion. Made from brass, steel, or titanium with plus or minus 0.001 mm tolerances. Polished to reduce friction and increase efficiency. 3. Escapement mechanism, regulation of energy release. The escapement is the heartbeat of the clock, ensuring controlled energy release. Types of escapements. Anchor escapement common in pendulum clocks. Graham, deadbeat escapement, high-precision regulators. Swiss lever escapement used in luxury watches, for balance, wheel, and pendulum time regulation. Pendulum clocks rely on gravity to maintain a steady oscillation. Balance wheels and small clocks use a fine-tuned hairspring for precision. B. Hand assembling a mechanical movement. Precision milling of components. CNC machines carve gears with microscopic accuracy. Jeweling. Synthetic ruby bearings reduce friction at pivots. Manual escapement adjustment. The escapement is aligned under a microscope. Hand polishing techniques ensure smooth gear engagement. Testing for accuracy. Time grapher machines check oscillation rates. Clocks are tested in multiple positions to check performance in real-world conditions. 2. High-tech automation in clock manufacturing. Modern factories use cutting-edge robotics, AI, and automation to mass-produce quartz and hybrid clocks. A. Robotic assembly lines. Automated CNC machines cut clock parts with plus or minus 0.0001 mm accuracy. AI-powered robotic arms handle delicate component placement. Automated lubrication systems apply microdroplets of synthetic oil. AI-based quality control. Machine vision systems scan clock movements for imperfections. X-ray inspections verify internal gear alignments. C. Quartz and atomic clock production. Silicon microprocessors regulate quartz movements. Laser-calibrated atomic clocks use cesium atoms for extreme accuracy. Loses 1 second in 100 million years. 3. Luxury clock and watchmaking techniques. Premium mechanical clocks and watches use traditional handcrafting methods, ensuring superior durability, elegance, and exclusivity. A. Hand finishing techniques. 1. Engraving. Intricate, repetitive patterns engraved onto the dial or case. Done using a Rose engine lathe for exquisite texture. 2. Hand beveling, anglage, edges of gears. bridges, and plates are hand-polished at a 45 angle, increases visual appeal and reduces microscopic wear. 3. Pearlized finishing. Tiny, overlapping circles are applied to movement plates, seen through transparent casebacks and luxury clocks. The high-end material selection. 18K gold and platinum, used in luxury clock cases. Titanium alloys, lightweight yet hand-cut sapphire crystal, scratch-resistant clock faces. See tourbillon clocks and watches. A tourbillon mechanism counteracts gravity's effects on the found in premium timepieces, $50,000 plus range. For innovations in next-generation clocks. AI-driven smart clocks. Self-learning algorithms adjust timekeeping based on user habits. IoT integration syncs with home automation systems. The energy-efficient movements. Perpetual motion-inspired systems minimize energy loss. Kinetic-powered wall clocks use ambient vibrations to see. Hybrid quartz mechanical clocks. Combine quartz precision with traditional gear movement. Luxury clock and watch brands. Explore brands like Patek Philippe, Jaeger-LeCoultre, Rolex, Atmos clocks, and their exclusive craftsmanship techniques. Smart clock innovations. Learn about AI-driven clocks, IoT integration, voice control, and next-gen atomic clocks. Handcrafted mechanical techniques. A deep dive into traditional watchmaking methods, finishing techniques and tourbillon movements. Advanced materials in clockmaking. Understand high-tech materials like titanium, ceramic composites, and synthetic sapphire. Feature automatic time correction using radio signals.